A warm greeting to all. Today in this video we are going to discuss about Unit 3 on DSP, Discrete Fourier Transform and Commutation. So these are all the syllabus to be covered under this unit. So we can split this syllabus into three modules. In very first module we are going to discuss about Discrete Fourier Transform and its properties and with representation of discrete Fourier transform. And in module 2 we are going to discuss about DIT algorithm, that is decimation in time, and in module 3 we are going to discuss about DIF, that is decimation in frequency algorithm. So let's move on to the syllabus. So before starting the introduction on DFT, let's discuss about the different transforms available. So this Fourier transform, we all know that is Laplace transform. It is going to convert a continuous time signal to a continuous frequency signal. In second unit we have discussed Z transform and DTFT. DTFT is the derived version of Z transform, and this is going to convert discrete time domain into a continuous frequency domain. And now in this unit discrete Fourier transform is going to be discussed, and it is going to convert discrete time signal into a discrete frequency signal. So the difference is the output in frequency domain is continuous in DTFT, and whereas in DFT we are going to get a discrete frequency signal. So the difference is the output is getting varied. So here in second unit we are getting a continuous form of frequency. In this unit we are going to discuss about discrete form of frequency, and we can relate these two outputs. We can get discrete form of frequency from this continuous form of frequency by applying sampling process. And we all know for getting discrete signal from a continuous signal we need sampling process. For getting digital signal from a discrete signal we require quantization and encoding process. So simply by sampling the output of DTFT we are going to get DFT, that is discrete frequency signal. And another important thing that we have to compare with DTFT and DFT is we can apply this DTFT for infinite length of sequences, whereas DFT for finite length of sequences. And the reason for getting the discrete form of frequency is nowadays we are computing all such frequency analysis by using digital computer. So for digital computer, if we are going to employ DTFT, it is going to compute the values from minus infinity to plus infinity. So it required more computational time as well as more memory size. So in order to avoid such large requirement of memory size, we are using DFT, because in which we are going to apply only finite length of sequences. So in digital computer we can compute the frequency analysis of a signal very easily. The time consumption is very less comparing to DTFT, and also it required only a smaller memory size. So because of this main reason we are using DFT in practical, not DTFT in practice. Now move on to the mathematical expressions for all the transforms. If we are having for all the in second unit also we require discrete time signal, and in this unit also we require discrete time signal. So the representation of discrete time signal is x of n. If we are going to apply Z transform, we will get x of z. We know the value z is r e power j omega. And if you want to get a complete frequency signal, we have to apply DTFT. The representation is x of e power j omega, and we know the value of e power j omega is, we can get this value by applying the value of r as 1 in z equation. Now if you want to get the frequency in DTFT is continuous. So for getting a discrete value of this frequency, we are going to apply sampling theorem to this equation. So by applying sampling method, we can get digital form of this discrete form of frequency. So this is the representation is discrete form is x of k. So directly, so this process we are calling as DFT, and this is the general mathematical equation for x of z. So the length is varies from minus infinity to plus infinity. And now if you are going to substitute the value of z as r e power j omega, and by making r as 1, we can get the expression for continuous frequency domain signal, that is x of e power j omega. That is the equation of DTFT. Now if you are going to apply sampling method to this DTFT, we will get DFT, that is x of k. And for sampling, we are going to substitute the value of omega as 2 pi n by 2 pi k by n. And here we have substituted or replaced the value of omega as 2 pi k by n, and this is the discrete form of a frequency signal.